Hello everyone, hope you're doing well. My name is Tawfiq Omar Uthman, math teacher. In this video, I will explain Chapter 1, Function and their graphs, Lesson 3, Part F, Domain and the range of composition function. Composition function. Joining two or more function to make one function by using summation or any other operation, like example fx equal 2x plus 2 and gx equal x squared plus 2x plus 3. We have two functions. To find a composition function by summation, you can say f plus gx. Only find the summation of these two functions. First of all, 2x plus 2 plus then x squared minus 2x plus 3. And now write x squared before, then cancelling 2x with 2x and finding the summation of 2 plus 3 is 5. Therefore, the f of gx is equal x squared plus 5, which is a new function. If you want to use a subtraction, then f minus gx, write fx 2x plus 2, then minus, then open a bracket and write gx inside this bracket, x squared minus 2x plus 3. First of all, open this bracket, then write 2x plus 2 as same, then minus time plus is minus, minus time minus is plus, and minus time plus is minus. And now write minus x squared before, then you have for 2, you have 2x plus 2x it equal 4x, and you have plus 2 and minus 3, it become minus x squared plus 4x minus 1 is a new function. To find f gx, first of all write 2x plus 2 and then open another bracket and write gx inside x squared minus 2x plus 3. 2x times x squared is 2x cubed. 2x times minus 2x minus 4x squared. 2x times 3 plus 6x, and then 2 times x squared is 2x squared. 2 times minus 2x minus 4x. 2 times 3 is plus 6. And now write 2x cubed. Then you have minus 4x squared and plus 2x squared, it become minus 2x squared, and you have plus 6x and minus 4x, there it become 2x, right, plus 6. Therefore f times gx is equal to x cubed minus 2x squared plus 2x plus 6. To find the domain and the range of this kind of the function, it's better first time find the function, after that try find the domain and the range. Example number 1. Find the domain of the function g of f where fx is equal x square minus 1 and gx equals square root of x. First of all, let us find the function g of fx. It is g of x. Write in place of f of x, x square minus 1. It becomes g of x square minus 1. And now write x square minus 1 in place of this x. It becomes square root of x square minus 1. To find the domain of square root, take under the square root bigger or equal to 0. And now take minus 1 from left side to right side, then it becomes x square bigger or equal 1. The solution of this inequality is x less than equal minus 1 or x bigger than or equal 1. Therefore, the domain is minus infinity to minus 1 and union 1 to the positive infinity, as you can see in the graph of the function, coming from minus infinity to minus 1, after that from 1 to the positive infinity. Because the sign of the square root was positive, therefore this function range is all positive number. That means range is from 0 to the positive infinity. Example number 2. Find the domain of the function g of f where fx is equal x square minus 1 and gx is equal 1 over x. Find first of all g of f x, which is g of x, and now write in place of fx x square minus 1, therefore g is x square minus 1 is equal, and now write x square minus 1 in place of this x. It becomes 1 over x square minus 1. Because we have a rational function, then x square minus 1 is not equal to 0. Therefore, x square not equal to 1 by taking the minus 1 from left to the right and take a square root of both sides. Therefore, x is not equal plus or minus 1. Then domain is all real number except minus 1 and 1. Example number 3. Find f of g where fx equal 4 minus 2x square and gx equal 2 minus x. f of gx is equal fgx, and now write gx in place of gx. It becomes f of 2 minus x, and now in place of each x here write 2 minus x, become 4 minus 2. In place of x write 2 minus x and then square. Open the bracket. 4 minus 2. 2 square is 4. 2 times minus x minus 2 is minus 4x. Minus x times minus x is plus x square. And then 2 times 4 is 8. Minus 2 times minus 4x is plus 8x. Minus 2 times plus x squared is minus 2x squared. It becomes minus 2x squared plus 8x. 4 minus 8 is minus 4. The right answer is D. Domain or real number. Example number 4. Find fg of 3 where fx is x and gx is x squared. fg3, first of all find f3 and g3. f3 is 3, replacing 3 in place of x. g3 is 3 square minus 7. 3 square is 9, minus 7 is 2. And now fg3 is f3 times g3, which equal f3 is 3 times g3 is 2. Therefore 3 times 2 is 6. That means fg3 is 6. The D is a correct answer. Example number 5. If fg3 is equal 16 and gx is equal x plus 1 over x plus 2, then find f of 3. To find fg3, we must have g3 and f3. We can find g3 by replacing 3 in g. Therefore, g of 3 is equal 3 plus 1 over 3 plus 2. It becomes 4 over 5. fg3 is equal f3 times g3. fg3 is equal to 16. It equal f3 is unknown, g3 is 4 over 5. And now multiplying both sides by 5 over 4, that means 16 times 5 over 4 equal f of 3. And cancelling 4 with 16, remain here 4. That means 4 times 5 is 20. Therefore f of 3 is 20. That means D is a correct answer. Example number 6. If g of x is equal 0.5 and gx equal cosine x and fx is equal 2 pi over 2x minus 1 at interval 0 and 2 pi, which of the values of x satisfy this condition? g of x equal gfx, which equal g of 2 pi over 2x minus 1 by replacing 2 pi over 2x minus 1 in place of fx, and now replacing 2 pi over 2x minus 1 in gx, it become cosine 2 pi over 2x minus 1. Therefore, g of fx is equal cosine 2 pi over 2x minus 1. But we have that g of fx is equal 0.5. That means cosine of 2 pi over 2x minus 1 is equal 0.5. Because 0.5 is positive, therefore the cosine is at a first quarter and or a fourth quarter. Because we have 0.5, that means we have the pi over 3, the value of angle. Therefore, at Q1, 2 pi, the angle 2 pi over 2x minus 1 is equal pi over 3. Make a cross there, pi times 2x minus 1 and 2 pi times 3 is 6 pi. Dividing both sides by pi, then 2x minus 1 is equal 6. Take 1 to the from left to right, that becomes 6 plus 1 is 7. Then divided by 2, that means x equal 7 over 2. That is the first value as we have here. Let us search for the second value at quarter number 4. At quarter 4, the value of angle 2 pi over 2x minus 1 is equal to pi minus pi over 3. By simplifying this equation, x is equal 1.1. We have this value here. That means B is a correct answer. Example number 7. If gx equals sine x and fx equal to x squared, then fogx is equal fgx which equal f of gx is sine, write sine in sine x, and then write sine x in fx in place of x. Then it's become 2. We have x, it is sine x, x squared, that means sine square x. That means A is a correct answer. Example number 8. If gx equal 2 minus x and fx is equal 4 minus x squared, then g of x is equal. G of x is equal g of x, which equal g of fx is 4 minus x squared, and replace 4 minus x squared in g in place of x, become 2 minus 4 minus x squared. Open the bracket, 2 minus 4 plus x squared, it is x squared. 2 minus 4 is minus 2. That means C is a correct answer. Example number 9. If gx is equal 1 over x and fx is equal square root of x squared minus 4, find domain of the function g of x. First of all, let's find the g of x. It is g of x. It is g of square root of x squared minus 1, replacing here, become 1 over square root of x squared minus 4. And now to find the domain of this function, take under square root only bigger than 0. Therefore, x squared minus 4 is bigger than 0. Taking minus 4 from left to right, x squared bigger than 4. Therefore, x less than minus 2 or x bigger than 2. That means the domain is from minus infinity to minus 2 and 2 to positive infinity. Example number 10. If gx equals square root of x and fx equals square root of x minus 1, find domain of the function g plus fx. First of all, let us find g plus fx. It is square root of x plus square root of x minus 1. To find the domain of this function, first of all, find the domain of square root of x, which is gx. Because we have a square root, take under square root bigger or equal to 0. That means the domain of this function gx is equal from 0 to the positive infinity. And now let us take the second square root, take under square root x minus 1 bigger or equal than 0, then it becomes x bigger or equal than 1. That means the domain of function fx is from 1 to the positive infinity. And now the first domain is from 0 to the positive infinity, and the domain of fx is from 1 to the positive infinity. The intersection of these two intervals is domain of g plus fx, which is from 1 to the positive infinity. Domain is from 1 to the positive infinity. Example number 11. If gx equals square root of x plus 1 and fx equal to square root of x plus 2, find the domain of the function g minus fx. First of all, let us find the domain of each of fx and gx. For gx, as you can see, take under square root x plus 1 bigger or equal to 0. Then x is bigger or equal minus 1. And here x plus 2 is bigger or equal to 0. That means x is bigger or equal minus 2. First of all, let us find the function g minus fx. G minus fx is square root of x plus 1 minus square root of x plus 2. The domain of gx is from minus 1 to the positive infinity. And now we have minus 1 here, and domain of the g is bigger than minus 1 to the positive infinity. And the domain of the function fx is from minus 2 to the positive infinity. That means all real number bigger than minus 2 or equal minus 2. Then the intersection between these two interval is from minus 1 to the positive infinity, which is domain is g plus fx, which equal from minus 1 to the positive infinity. From minus 1 to the positive infinity. Example number 13. If gx is equal absolute value of x plus 1 and fx is equal absolute value of x plus 2, then the domain of the function g plus fx is equal. G plus fx is equal absolute value of x plus 1 plus absolute value of x plus 2. The domain of the absolute value is all real number. Therefore, the domain of gx is all real number, and the domain of fx is all real number. Therefore, the domain of g plus fx is all real number. Here we came to the end of the video. Please share it with your friends and write your comment and subscribe the page. Also ring a bell. Thank you for watching and goodbye.